So in 3.1.5, it says we're going to roll a fair die 8 times, and we want to calculate different probabilities. So part A says find the probability of our 5 even numbers. So what we need to do is first figure out what would be the probability of getting an even number. So every time we roll the die, even means you could get a 2, 4, or 6. So the probability of getting an even number would be 1/2. Now each die roll should be independent of the next die roll. Each die roll could either be even or odd. Okay, each die roll we have a 1/3 probability of getting an even. So everything we're supposed to do for a binomial distribution works. So this is going to be a binomial with p equals 1/2. We know we're rolling it 8 times. So that was the last thing for binomial. We know we're doing it 8 times. It's binomial, 8 n equals 8, and we want to find the probability that x equals 5. Once you know that, it's a simple matter of plugging it into the formula, which may not be simple to evaluate, but at least now we know what we're supposed to do. So our binomial probability formula, probability that x equals a specific value, is going to be, and choose x, p to the x, 1 minus p to the n minus x. So the probability that x equals 5 is going to be 8, choose 5, times, remember our probability is 1/2, so 1/2 to the power of 5, times 1 minus 1/2 to the power of 8 minus 5. Now remember that 8 choose 5, that's your binomial coefficient. You can put that into your calculator or go look up the formula to figure that out. So this gives me 0.21875. So I'm betting the harder part of this problem is just figuring out what your p and n and x value are that you're looking for. So like part B says exactly 1/6. Okay, now each of these is going to be a new setup for the binomial distribution because we're looking for new things. So we want to get 1/6. There's not really a good way to write that out. Exactly 1/6. Okay, well again, we know we're doing it 8 times. Each die roll should be independent. What's the probability of getting a 6? Well, to get a 6, that would be 1 out of 6. So we know it's binomial, we know n, we know p. All we have to do is plug it in. We're looking for the probability that x equals 1. So you can do that one. Part C says no 4s. So this is how I would set it up. It wouldn't be the only way you could do it, but we're still doing it 8 times. And the probability, this would be the easiest way to do it. The probability of a 4 is 1/6. Okay, so we're going to do a binomial. N equals 8, p equals 1/6, but we're looking for the probability that x equals 0 because we don't want any 4s. There are other ways you could do that. That would be the easiest, and we are doing a binomial distribution, so it makes sense to do it that way.